Okay. Um, so consider the paraboloid z equals x squared plus y squared, and it's cut by this plane 10x take away 10y plus z minus 6 equals 0. And it's going to create a, well, it's actually going to create an ellipse. Um, because the cross sections of this paraboloid, if you intersect this parabola here, the z equals x squared plus y squared with planes that are parallel to the xy plane, you'll get circles. This thing's going to be tilting, so it's going to create an ellipse. Well, let's see what we get. All right, so and it gives you a whole bunch of directions here. The curve, blah blah blah. What's the natural parameterization? You know what? Sometimes that's just more confusing than anything. Let's just pretend we don't see that. Let's just roll up our sleeves and tackle it directly. Okay. So, um, so you look at these two things and you say, you're trying to find where they intersect. You notice that they both have single z's. Now, because these have quadratics for x and y, I wouldn't want to mess with those. But these both have single z's. So it makes sense to make a substitution. So I'm going to solve for z on this one. I'm going to bring everything to the right side. I get 6 take away 10x plus 10y. And then I'm going to plug that in up here. And I'm going to just write it all out. It's going to be 6 take away 10x plus 10y equals x squared plus y squared. And now what I'm going to do is I'm going to bring all that to one side. It's going to be x squared plus 10x. And I'm going to leave some space. So I'm actually bringing this up to the right side now. Plus y squared take away 10y. And then and then the 6 comes over, blah blah blah. Where am I? -6. Okay. Okay, so I basically brought everything on the left side to the right side. You want to make sure I didn't screw that up. So let's see. That should just be a +6. I left it alone. Okay. So what I'm going to do next is I'm going to complete the square. This is, all right, this is actually a circle. Okay. My bad. I said ellipse. Let's complete the square twice. So half of 10 is 5. Square of 25 is 25. So I got to put it there and over here. And then same thing here, half of -10 is -5. Square, you get plus 25, so you get another 25 here. And you get 56. Okay. I'll pause here. So far, so good. Here, you see what I did there? Feel free to jump in if you don't. Okay. So I'm just going to review. I think I want to make sure I didn't screw something up here. So basically, I was kind of writing all this to bring these guys. So I said I left the 6. So the 6, oh, that should be a +6. So I'm feeling pretty good about that. Let's see. All right. So what do I have here is I have a circle. This thing is a circle. It's centered at -5 plus 5, and its radius is square root 56. Okay. Um, so now that what it comes time to the natural parameterization. And so normally when you parameterize a circle, you let x be the cosine of theta and y be the sine of theta. But what we're going to do here is we're going to include the x plus 5. So we're going to say x plus 5 is actually the cosine of theta, but I need to account for the radius, so I pop that rad 56 in front. And similarly, the y minus 5 is going to equal rad 56 sine theta. And then you just do a couple quickie, just move the 5's over and you get x equals -5 plus rad 56 cos theta. Y is going to be plus 5 plus rad 56 sine theta. And of course, that theta will be between 0 and 2 pi. And then z, pardon me, what you do is go all the way back up to the original equation up here. And z is just these two things. I wouldn't even bother trying to spread them out. I would just pop them in like that and leave it alone. Um, this was from Harlan. Did this help you? Did anybody else have any questions on this one? It's a kind of a complicated question. Okay, thanks. Good deal. It's complicated, but at the same time, I guess there's really only one sensible way to do it would be to attack it with the easiest variables. And the fact that both of them have linear z's in it is where I would start. And then you basically just start, blobbing them together and watch out for your arithmetic. There is a question that was like this in the ed discussion, so this is good that this came up again. Let me, well, I'm going to do it the only way I know how to do it. It's very,
Okay.
it's very possible that you just made an arithmetic mistake somewhere. The cross
I
product
don't
is
know.
very easy to mess up. There's
Oh,
so many opportunities to multiply something or add something wrong. So I've copied down the 3 points, and they were asked to find the equation of a plane containing these 3 points. And so I'm gonna go to my overhead now. And so I'm gonna do like what you said, just create a couple of vectors. A to B is good ones. So we subtract A from B. So 8 minus 5 is 3. -4 minus -5 is -4 plus 5, which is 1. 2 minus -3 is 2 plus 3, which is 5. And then AC. Now, again, this is just arbitrary. I could do BC if I wanted. It should work out no matter what. 8 minus 5 is 3 again. -3 minus -5 is -3 plus 5, which is 2. Then we have 4 minus -3, which is 4 plus 3, which is 7. So the first order of business is to make sure that you don't even make a silly mistake early on. If I messed up like a little arithmetic here, that would throw everything out going forward. Um, so the cross product formula, as I know it, is to do a 3 by 3 determinant. Pop the numbers in. Then you create a whole bunch of minors. Whoops, that should be an I. Then you have minus the minor of J, and then you have plus the minor of K. Now again, be careful. The minor of I is going to be 1527. Minor of J is going to be 3537. And then the minor of K is going to be 3132. And notice, don't forget the um, minus sign automatic. That's a cofactor. Again, there's a lot of opportunities to just make a silly mistake. Let's see, I work
I
out.
forgot the minus sign needs to be in the middle there. The random
Yep.
minus sign. Oh, that's it right there. So glad I asked.
All right. Well, that's actually not a random minus sign. This is a characteristic of all determinants of matrices that they follow a checkerboard pattern of signs. And since we're expanding along the top row, it's always going to be plus, minus, plus. So that's important. Let's go ahead and finish this off. So we have 7 minus 10 is -3. We have 21 minus 15, which is 6, but then that negative pops on. And then we have 6 take away 3, which is 3. And so I get the cross product is -3, -6, +3. Now, before you move on to the next question, I know we haven't answered the question yet because we want the full plane, but this is something you should all do. Whenever you do a cross product, you need to make sure that it is correct. And the way to show that it's correct is to actually take its dot product with both of the original vectors. So for example, if I take the dot product of this thing with AB, let's see, -3 times 3 is -9. -6 times 1 is -6, so -9, take away 6 is -15. Plus 15 is 0. Boom, that works. You should get 0. The cross product is orthogonal to the original two vectors. Let me check it with this guy. -3 and 3 is -9. -6 and 2 is -12. So -9 take away 12 is -21. Aha, plus 21. It's beautiful. This is correct. I 100% sure of that. And so, yeah, you missed that negative. That would probably make that a plus sign right there. And that would throw you off. To finish the question off, we wanted the plane. So it's -3x, -6y, plus 3z. And then we just need to figure out what the constant is. And you can take any one of the 3 original points and plug it in. I'll take the first one. So let's do 5. So let me just kind of lightly below 5, -5. -3. So I get -15. We're gonna get +30 and -9, so 6. I think that's the answer. Let me double check that. It looks about right. No, hold on. No, that's right. All right. But I can also check that by taking another point. If I take the 0.8 -4, 2, let's try that. 8, that'd be -24. -4 here. So negative. Yeah, that works. Okay, so I get 6 as well too. Beautiful. All right, cool. Does that help? Did I answer your question?
Yeah, that definitely helps. I have another one that I haven't solved yet, but I
Okay.
want to give other people a chance to ask questions before I have another one.
All right, no problem. So I'm going to try to find uh, the Test Yourself PDF number 17. So I'm going to go to my website here in a second. Let's see. Okay, actually, there's a couple of, Christopher, there's a few different test yourselves floating around out there. I'm going to share the screen with what I have. And you let me know if this is the right one. Is it this one right here? Yay or nay? Let's see, chat. It is? Okay, good. Okay. All right, I'll go ahead and do this one. Let me get the information here. So the question is number 17. I need to get the information here. So the vector W is given as -4, 1, and 6. And we had to figure out a plane that contained U and V. Let me copy that information. Now, so we're going to get a lot of good stuff here. 2, 1, -3 for U. V is 5, 4, 2. All right. It includes the point 2, 0, 1. All right, pardon me. All right, so let's go ahead and work this one out. So let's do the plane first. That was just like the one we just got done doing, but it's always good to review. We need to find the n vector that is orthogonal to the plane. So we do the 3 by 3 determinant. Oops, didn't mean that negative. That should not be a negative. All right, do the minors. So for I, let's see, remember that negative in front of the j. And then we have k. So the minor of I is 1, -3, 4, 2. Minor of j is 2, -3, 5, 2. And k is 2, 1, 5, 4. We figure it out. We get 2 take away 12 is 14i. Here we get 4 plus 15 is 19, so -19j. Then we get 8 take away 5 is 3. So the n vector for this plane should be 14, -19, and 3. And I would double check that just by working out a quick like dot product. So 14 times 2 is 28. Take away 19 is 9. Take away 9 is 9. Okay, it's 0. Beautiful. All right, so I feel pretty good about this. Now I'm going to show you something here. I'm actually good. I'm good to go with this problem. All I need to know is the n vector to the plane. So this is kind of a visualization thing. You've got a vector sticking out at 90 degrees to the plane. That's this guy right here. Okay. Meanwhile, you've got this other vector, -4, 1, and 6, that's just kind of doing its thing. Let's just say it's right here. Okay, let's just say that's -4, 1, and 6. Okay. Now, what I can do is I can find the angle between the vector and the n vector. That's not the angle relative to the plane, but we're getting there. What I do there is I do I do that arc cosine, use the dot product. So I have to do, in this case, n dot w, and then this would be rad n, I'm sorry, mag n, mag w. All right, let's work this out real quick. N dot w, 14 times -4 plus -19 plus 18. I get -57. And then the radicals, what do we got here? We got oh geez, 14 squared plus 19 squared plus 9. That's rad 566. Running out of space here. And then we have 24, 25, 16. So 25 is 41. So I'm going to do inverse cosine. I want to be in degree mode. Yep, I'm in degree mode. So I'm going to do inverse cosine, -57 divided by rad. And I can combine the rads into a single one. So 566 times 41. And when I'm all done, I get this big number. I get theta equals 111.97 degrees. All right. Now, here's what's going on. Now, I had no idea when I drew this picture that's what it was going to look like. It turns out that these are obtuse angles. It turns out, in a sense, in fact, now that I have the angle, it turns out that if the n vector's here, my w vector is actually down here. And it's created an obtuse angle of 111.97 degrees. Well, we know that the n vector is at 90 degrees. So I just take the difference, and that's the answer to the question. So the answer to the question would be 111.97, take away 90. And that's going to be, what's that, 21.97. And I'll admit, there's a lot of thinking, a lot of kind of visualization going on here. Um, I don't know any easier way to do that. This is not something that can be boiled down to one single formula because there's a lot of twists and turns in these types of questions that you have to make some judgment calls as you go along. In fact, if I came up to the original problem here and I actually worked out V cross U and flipped these, then actually my vectors would be acute. And I would just take the complement of the angle rather than the difference from 90. So it's a slightly different question. Okay, I hope that helps. I know it doesn't answer all your questions at once, but that's kind of the challenge here. And I do have examples like this in my notes on my website. Um, just to make sure you all know that, I'm going to type it in here, www.surgeon.net. You go to /math and oops, spelled it. Should know how to spell my name right. And then you can check out my examples. They're buried in there, but I have something that closely matches just about everything in infinity. So question is, am I correct in thinking that if the question is asking for intersecting or orthogonal, there will be some form of cross product? Yeah, okay, so I'm going to read the question in case it doesn't show up. Am I correct in thinking that if a question is asking for intersecting or orthogonal, there will be some form of cross product? And if it asks about parallel, you will use something with the form of the dot product? Honestly, I can't say definitively yes or no. It's going to be a mixed bag. You basically have two very powerful tools now, the dot product and the cross product at your disposal. And it, it's it would be hard for me to say that definitely, in this case, definitely cross product. I don't want to, so unfortunately, I'm not going to give you a very strong answer. I'm going to basically say, unfortunately, no. Uh, it's going to be a mixed bag. Just be ready to try everything. Um, Again, just kind of follow through a lot of the questions that are on the examples and see if you can't start to kind of develop a sense of how the tools were used. That's the hope. Okay. Again, I wish I could just boil it down to a formula, but unfortunately, it doesn't quite do work that way. All right, so this is 10.5, number 10. You have two lines. You need to show if they're parallel or skew or they intersect. All right. Well, the parallel is easy. Just look at the coefficients of the parameters. This one has a direction vector of 4, 2, 6. This one has a direction vector of 5, 4, 9. These are not multiples of each other. So they're not parallel. All right, so that part's easy. Okay. Now what we're going to do is we're going to see if they intersect. We're going to try to force it. So you take the equations. So I'll take the x's. And I'm going to set them equal to each other. 17 plus 4s is going to be equal to negative 5 plus 5t. And then I'll take the y's and I'll do the same thing. 1 plus 2s is equal to negative 13 plus 4t. Now this is a solvable system because it's two variables and two equations. I should be able to get an answer. So let me rewrite this so that it's a little more traditional looking. I'll bring the variables to the left side. So 4s and 2s stay where they are. Let's bring these guys over. So I've got negative 5t and negative 4t. And then let's bring the constants to the right. So negative 5 take away negative 7. I'm sorry, negative 5 take away 17 is negative 22. Negative 13 take away 1 is negative 14. So that's a little more of a traditional system now. And see, and then now I don't care how you guys solve this. Whatever works for you is fine with me. I think on this one I'm going to go ahead and multiply the bottom by negative 2. That'll get rid of the s's. Let's see, negative 4s plus 8t equals 28. So the s's cancel. I've got 3t equals 6, so t is 2. And then when I work backwards and I get what my s is, if t is 2, that would be 10. So plus 10, so that'd be 4s equals negative 12. So s should be negative 3. And let's just double check. If I put a negative 3 here, that's negative 6. 2 there, negative 8. Okay, that works out. Okay, great. Now, here's the big thing. I only did it for x and y, right? So what about z? Well, we got to take the z equations up here. I'll put an equals question mark. It's either going to work or it's not going to work. This is what's called an overdescribed system. If you take linear algebra, which you should, anytime you have a system that has more equations than variables, it's called overdescribed. And they usually don't have a solution. But sometimes they do. Well, let's see. Anyway, so what I'm going to do is I'm going to plug in what I got for s and t. So s was negative 3. And t was 2. And it's looking like it's going to work. And I get 0 here and I get 0 here. And gosh darn it, it looks like it works. All right. Well, it worked.
Good for you. Yeah, I'll start with
Well,
just doing the X and Y. I was doing it totally different.
let me say
So
this. If it doesn't work, that's an answer. If it doesn't work, it's called skew. The two lines don't intersect. Since it does work, now you know what the S and T values are. Just go back up to the original equations, just pop in your S, what was S? Negative 3, just boom, 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 get your X, Y, Z. You put your T in there, you should get the same X, Y, and Z.
yeah, beautiful. Thank you.
Sure. All right, so we have a question here. So this is two lines that we are seeing if they're parallel or if they're the same line, actually. So if they could be parallel and skew, which means they don't intersect, or they could be parallel and actually be the same line. That's what we're wondering about. So they are parallel because the direction vectors are multiples of one another. You can see that the second one's double the first one, so that's good. The second one is kind of like what I did before. Uh, there's a couple ways to do this, but for example, what I did on this one is I picked 1, 2, 5. I know that's a point on the first line. And so basically I try to force it to work. If these two are the same line, if L1 and L2 are the same line, they should pass through 1, 2, 5. So let's try to make L2 pass through 1, 2, 5. And so what I do is I just force it. I just set 1 equal to 6 plus 4s, 2 equal to 1 plus 8s, and 5 equal to -2, -6s. And when I solve for s in each case, I don't get the same s each time, and that's the problem. That's what I mean by not unique. It should be the same s. Otherwise, it doesn't work. So in this case, these are not the same line. They are skew parallel lines. That's all I meant by that.
Oh, okay. Thank you.
That help? Okay. Sorry about the little hiccup there. I'm not sure why it wasn't loading up. Maybe it's just overwhelmed right now. And this is the one you're asking about, right?
Yeah, that's the one.
Okay. Let me copy the information. So we have base curve. It's t squared, 2t take away 3, 4t take away t cubed. We want to find velocity at 3 seconds and the acceleration at 3 seconds. And then we want to find the speed at 5. Okay. So the velocity will just be the derivative. We'll just take a derivative. So far, so good. And then we
Yeah.
put in at 3, we just pop the number 3 in there. We get 6, 2. What do we get here? We get 4 take away 27, which is -23. Acceleration is the derivative of velocity, the double derivative of r. So we get 2, 0, and then -6t. And we pop in the 3 there. We get, well, nothing changes there. We get 2, 0, and then -18. Okay, so far so good.
Yeah.
I'll say this for looking ahead, you're going to be doing a lot of what's called big T. And big T, if you haven't already seen it, is basically r prime divided by its magnitude. It's a big thing. It's a big deal later on, so just be aware of that. Speed at 5. So the velocity at 5 is you're going to just pop the numbers in. You get 10, 2, and then at 5 here you get what 25. So 4 take away 75 is -71. And then the speed is the magnitude of that. So speed is just magnitude of velocity. And then you just work out the Pythagorean theorem. So 10 squared plus 2 squared plus -71 squared, blah, 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 blah. You get 104, and I kind of know my 71, so I'm going to look that up. So 5041 plus 104, so you get 5145 square root, which comes out to about 71.72 units per second or whatever, meters per second. Does that help? Zoe, was that you?
Yeah, that's actually like really easy.
Okay. We
Thank
have time.
you.
Sure, no problem. We have time for one more. It's Ben. Can we go over 10-7, number 16? We sure can. Give me a second to find it. So 10-7, number 16. All right. Yay. All right, so I'm gonna share a screen. So here's the question. I think I did figure out what my mic problem is. You know, when I lean into my paper, I'm actually blocking camera slightly, so I'll keep that in mind. Number 16. So find a vector parametric equation, R of t, for the line to the points. Okay, okay. Yeah. All right. You know what? I'm gonna cheat slightly. I'm gonna show you something. Let me copy the first one. Now, the first one is from, we want R0 to be the first point, 5, -5, 0. And we want the second point, which is at 6, to be 5, -8, 3. All right. I'm gonna actually cheat, not in the bad sense, but I actually have something for this. Let me go to my website and see if I can bring it up. Yeah, I'm going to bring up the HTML version. It's not the best looking thing in the world, but because it's not loading up the big files. So it's right here. Okay. So basically, the parametric equation for a line can be done many different ways. You have the initial point, the x naught, y naught, v naught. And then you have this middle bit here. Basically, you have a shift and a shrink. The shift is the A, so we're actually not shifting at all. So A is 0. So I'll copy the formula. And then, of course, right here, all you have are the difference in the 2 points given. So nothing different there. And I'll give you a little discussion on this one too, because I have some feelings about it. So I'm going to stop the share. To be honest with you, you'll never do this. You'll never go from 0 to 6. There's just no reason to. But let's go ahead and do it anyway. A, basically you have an interval from A to B. Okay. So A in this case is 0 and B is 6. And you just pop the numbers in. So basically what you have here is x naught, y naught, v naught plus, and then t over 6, because B is 6, A is 0. And then over here, let's go ahead and do the difference values. We have 5 minus 5 is 0. -8 minus 5 is -8 plus 5, so -3. -3 minus 0 is 3. And actually, I could have gone ahead and put the first numbers in, so why don't I do that right now? And that's the line for the first one. And if you check it out, if you put the 0 in for t, you just get the first point. If you put 6 in, well, 6 over 6 is 1. And then suddenly these two guys just make up this point over here. Okay. Now this can be done with any other point. I mean, what if we said R of 2 is the first point and R of 11, oops, I didn't do that. R of 11 is the second point. I mean, I'm just making up two t values. You wouldn't do that, but what if you could? Well, same thing. You set up the same way. You have your initial point. We'll call that 5, -5, 0. And then you just come over here. You build in the shift, which is the 2, so t minus 2. And then you build in the shrink, which is 11 minus 2, which is 9. And then you have the difference, 0, -3, 3. And you know what? You're done. I wouldn't even mess with that because that's good. I have some examples like that on my webpage where I actually go through and distribute and make it look pretty, but that's actually a legit answer. So my comment on this is that in practice, we'll always use t equals 0 and t equals 1. Okay, because those are the most natural boundaries. You kind of use them without really thinking about it. And also for later on, when we get to the module on vector calculus with line integrals and parameterization, you want to parameterize your paths in a convenient way because these will actually become bounds of the integral. And I'd rather you be integrating from 0 to 1 than from like 2 to 11. So a lot of times when you're when you're parameterizing a path, you're trying to think like, what are the nice bounds? And then 0 and 1 is real nice. So it may not be really obvious now, but later on, this will become a big deal. Okay. All right. Well, guys, I appreciate you guys showing up, and we had a good turnout tonight. And I'm going to go ahead and stop the